Hey everyone, I wanted to make a quick video here showing a way that I reduce fractions that is a little bit different. I know that I had mentioned this in class the other day, but wanted a quick video for it. This is how the book does it. I know that if the word, and I'm going to write it here, if cross-reducing makes sense to you, that's the way the book uses it, approaches fraction multiplications, and especially with more larger fractions like this. But I do it a little bit differently. This is the more efficient way and actually will be faster and for some students easier. But I know that earlier on it's deceptive because a lot of times when getting the common factor, students really wonder where's that coming from. And I think it's oftentimes even more confusing than what it is. The method that I normally show on this is a little bit lengthier, but I think is a lot more direct with what students would want to do. What I would do is just multiply these. We're going to get much larger numbers. Multiply top times top, bottom times bottom. You're going to get, it was 420. I think, Emerson, you were the one that did this in class with us, over 72. Now, this is correct. That's a correct answer, but we just need to reduce it. If the idea up here was to notice, oh, 3 goes into both of those, oh, 4, that's what's called cross-reducing. I kind of get confused. I think students often get confused with that. What I always like is even when you have large numbers aren't bad. We're using the calculator. It takes, quick punching it in with a little $2 Dollar General one could do this. What I do is look for the numbers 5, 2, and 3 in that order. And let me show you what I mean, because it's easy to know if 5 goes into a number. And I would even add to this. I would say 10, because if numbers that end in 0 are divisible by 10, if these were both ending in 0 or 5, I would divide both of them by 5. But the fact that we don't, okay, great, I get to skip that step. Where we commonly see this right now is I would say, well, 2 goes into both of those numbers. It's really easy to tell if 2 goes into a number. We divide the top by 2, we divide the bottom by 2, they're even. So if I were to say divide by 2 to each, I would just get 210 over 36, right? 420 divided by 2, 72 divided by 2, great. And then I would keep going. That's what I mean is this is going to be more steps. They're still both even. Divide by 2, divide by 2. It's more steps involved, but I like it that it's a lot more direct and there's a lot less opportunity to be misled or to get confused. 105 over 18, right? 210 divided by 2, 36 divided by 2, 18. Now, I would say, and the next one too, you'd see that they're no longer both even. Okay, so 2 is done. Now, 3 is kind of a stranger number. These are still somewhat large. I would just say in a calculator, just check divide by 3, and you'll notice 3 goes into it. I don't know if anyone knows how to tell if large numbers are divisible by 3. What you would do is add up the individual digits. So like 1 plus 0 plus 5 is 6. Since 3 goes into 6, 3 goes into 105. We wouldn't be expected to know that right off the bat. 1 plus 8 is 9. 3 goes into 9. 3 goes into 18. But I would just say punch into a calculator. And when you do, you just punch it in. And let me punch it in over here. 105 divided by 3. It does go into it evenly. I know that would be 33 plus 2 more. It's going to be 35. 105 divided by 3 and over 6. Now, you would notice, trying to divide by 3, you'd notice, well, it goes into 33 and 36. 3 doesn't work anymore either, even though 3 goes into 6, right? And we just wait until we can keep doing it as much as we can to both the top and the bottom. Now, I would caution you, the only one that would be weird and you would always wait for at the end is the number 7. 7 is, there's no rule for it. So you would just notice at the end, and I always like to talk about the football numbers, right? 7, 14, 21. It's like when the Broncos are scoring points, right? You would just be able to see that if 7 goes, and obviously it doesn't here. So you would be done. This would be fully reduced. And yes, you would then need to turn this into the improper fraction, the mixed number. But this is what I call the Schrank method. You'll hear me calling it chipping away is what I like to call this. It's very different from the way the book uses it, but I like it because it's a little bit more direct. And again, you'll hear me talk about the 5, 2, and the 3 a lot because it takes a little bit more work, but it's very simple and it's very direct work. And there's a lot less room for error. So let me know if there are questions. I hope this helps. Keep up the hard work, guys.